let's take a look at this Measuring the Earth Topic 2 review sheet. Let's see what we have here. All right, so first you should start by reading this information, because these review sheets will give you a series of information that can be used to answer the questions in it. They give you vocabulary words, coordinate system. All these vocabulary words could be multiple choice answers. So you should go through this and understand all of these vocabulary words. Read through this, the size and shape, what a model is. All the vocabulary words are highlighted within the reading packet. All right, so we have model. Model is a way of representing the properties of an object or system. All right, we have diagrams here. So this is a spherical shape of the Earth, some basic Earth dimensions. You could see that the polar diameter is 12,714, and the equatorial diameter is 12,756 kilometers. So you can see that these diameters are slightly larger at the equator than it is across the poles, from North Pole to South Pole. And if you look at the shape, you'll see the shape of the Earth isn't like a football or like an egg. Even though it slightly bulges, it's so slight that you don't even notice this isn't a circle. Okay, so that's some information. We have comparison of the atmosphere, hydrosphere, lithosphere, and the Earth's interior with densities, phases of matter, what's gas, liquid, or solid, or thickness, how thick it is. And we have a cross-section of the Earth. You can see here that the hydrosphere is just this thin line, across the top. It's hardly even noticeable. And then we have the atmosphere, outer space, and then the Earth's interior. All right, once again, you could read and get the composition. Atmosphere is 78% nitrogen, 21% oxygen. All right, all types of information over here. Hydrosphere, lithosphere, Earth's interior. So let's look at a question here. What object best represents a true scale model of the shape of the Earth? A table tennis ball, also known as a ping pong ball, a football, an egg, or a pear? Well, we just saw this right here. All right, so this is not a pear or an egg or a football shape. It's kind of just like a ping pong ball. So let's go over here. Let's pick our wonderful colors. And for the first one, we have the answer is number 1. Table tennis ball. Which of the following is not evidence that supports Earth's spherical shape? Well, photographs taken from outer space. We saw all this in our notes. Ships appearing to sink below the horizon, changes in seasons, or similarities in gravity at sea level all over the Earth. All right, so this is also in here, talking about the shape of the Earth. Ships appear to sink over the horizon. Photographs from space, gravity at sea level all over the Earth's surface. So all of these are right here in this whole section right here. This talks all about it. So, like I said, changing seasons is not mentioned in there. All of these other three, 1, 2, and 4 are mentioned. So 3 is the correct answer. So these are not, they're in our notes, but they're also in the reading here. All right, so in which group are the spheres of the Earth listed in order of increasing density? Increasing density means it becomes more and more dense. So the atmosphere is the least dense. The hydrosphere, water, is more dense than the atmosphere, and the lithosphere, or crust, is more dense than that. So our answer is number 1. Which makes up most of the Earth's surface? Is it the atmosphere, the lithosphere, or the hydrosphere? The hydrosphere. Once again, this is in our reading. All these are. The lower atmosphere and hydrosphere are bound to the Earth by the force of gravity. Okay, so magnetic fields, atmospheric pressure is good, but it's caused by gravity. atmospheric pressure is caused by gravity. Molecular bond is not true. What do the tropopause, stratopause, and mesopause all have in common? Each is an interface of two layers of the atmosphere. All right, so all of these PAUSE, all these pauses, if we look on our Earth Science reference table, right, I think it's page 11 or 13 here, for our atmospheres, all right? All right, right here, this is page 13. We could see that the mesopause, stratopause, and tropopause are all interfaces between two layers of the atmosphere. All right? Boop. As depth within the Earth's interior increases, the density, temperature, and pressure all increase. All right, so that's number 2. Once again, we can see this. All right, we have... Here is our densities, so 3 to 9 to 12. Okay, as we get lower and lower, 2.7, it gets more and more dense. It increases. We could see from 0 all the way in the pressure increases, and we could see that the temperature increases in this graph right here. So all increase. All right, the following diagram shows Earth's spheres. Which spheres are zones of the Earth's atmosphere? All right, so the asthenosphere and lithosphere are part of the Earth. The hydrosphere is the water layer. Troposphere, stratosphere, mesosphere, and thermosphere are all parts of the atmosphere. So it's not the hydrosphere, it's not the hydrosphere, it's not the hydrosphere. So 1, 3, and 4 are not the correct answer, but 2 is. The layer of bedrock near Earth's surface that forms a continuous shell around the Earth is called the, let's see, troposphere and stratosphere are part of the atmosphere, so that's not rock. Hydrosphere is water, that's not rock. So lithosphere is the correct answer. Oxygen is the most abundant element by volume in Earth's inner core, crust, hydrosphere, and troposphere. Well, this is the atmosphere. This is the Earth's crust. Let's look in our Earth Science reference table. All right, so we have our layers of the Earth is on page 1. All right, average. We have Earth's crust, troposphere. So oxygen. The crust, 94% by volume, 33 and 21. So the Earth's crust has the most oxygen per volume. Boop. So Earth's crust. What is and the inner core is iron and nickel mostly, if you didn't look at your other maps or your other things on the reference table. What is the approximate altitude of the mesopause in the atmosphere? Okay, so what we're going to do is we're going to go to we're looking for mesopause, and we're going to go to our atmosphere on page 13. All right, just to say the inner core is iron and nickel, the outer core is iron and nickel too, not oxygen. And we'll see the mesopause is approximately 80 kilometers or 50 miles around that area. 80 kilometers or 50 miles. So let's see what we have here. We have what is the approximate altitude of the mesopause? We have 50, 60, 82 kilometers. All right, that is approximately correct. 90 kilometers. Which statement most accurately describes Earth's atmosphere? The atmosphere is layered, with each layer possessing distinct characteristics. Why, that is true. That is true. The atmosphere is a mass of gases surrounding most of it. No, it's all the Earth, not most of it. The atmosphere's altitude is less than the... No, that's not true. The atmosphere is more dense than the hydrogen... No, that's not true either. So 1 is the correct answer. Which layer of the Earth's atmosphere contains no water vapor, has an atmospheric pressure of 0.1 atmospheres, and has an air temperature that increases with altitude? All right, air temperature. So we want 0.1 atmospheres, no water vapor. So let's look. All right, so water vapor. Well, there's no water vapor in the mesosphere and thermosphere, and we have a temperature that increases in the thermosphere. It decreases in the mesosphere. And what was our last question here? Oh, 0.1 atmospheres of pressure. So pressure, very small. That's the thermosphere. So our correct answer here is for thermosphere. The water sphere of the Earth is known as the hydrosphere. That was easy enough. That's in our reading, our notes. All this stuff's in our notes. 15. In the following diagrams, the dark zones at the surface of each wedge-shaped segment Earth represents average ocean depth. Which segment is drawn most nearly to scale? Well, let's look. We got a wedge right here. And we'll see that the hydrosphere is just this thin line. Just a thin line across the top here. So let's see. Ooh, this is the one with a thin line. 1 is the correct answer. The following maps shows Earth as viewed from the North Pole and from above the South Pole. Which statement is best supported by these maps? 1, most of the Earth's surface is land. Well, that's not true. This is all water over here. This is all water. Most of the Earth's landmass is in the southern hemisphere. Well, no, because look at all this landmass up here. This is the southern hemisphere. The geologic North Pole is the South Magnetic Pole. What? That's just crazy talk. Most of the Earth's surface is a hydrosphere. It's full of water. Yeah, that looks good. There, that's in our reading too. Which graph best represents the percentage of volume of the elements making up the Earth's hydrosphere? All right, so let's go to our Earth Science Reference Table and go to page 1. There it is. Hydrosphere. So it's 33% oxygen, 66% hydrogen. So that's twice as much oxygen or twice as much hydrogen as oxygen, and only 1% of other stuff. So let's look here. We have mostly hydrogen, some oxygen, and just a little bit of others. So 4 is the correct answer there. Here we have locating positions on Earth. So we have our North Pole, all these cities, all kinds of giggly goop. Ooh, the Big Dipper and the Little Dippers to find Polaris. And the altitude of Polaris, here it's at 30 degrees. That person's at 30 degrees north latitude because Polaris is at an altitude of 30 degrees. Here a person at 90 degrees has Polaris directly above at 90 degrees. Here's a person at 0 degrees, and if they look, the North Star is right on the horizon or 0 degrees above the Earth, 0 degrees altitude. They have a whole explanation about it here. Latitude, longitude, how to measure it, measuring local noon. That's the noon that's around here. That's me. Digging deeper. Oh, some more information. A couple little pictures here to look at. You can color them with a pencil. Polaris is used as a celestial reference point for Earth's latitude system because Polaris is located over the Earth's axis of rotation. Yeah, it's over the North Pole. Can be seen from any place? No, only in the north. Only in the north. It's very bright. It's not any brighter than most stuff. Always rises at sunset, sets at sunrise. No, it's always sitting in the sky, same place. So 2 is the correct answer. An airplane takes off from a location of 17 degrees south latitude and flies to a new position 55 degrees due north as its starting point. What latitude has the airplane reached? All right, so we started at south and we had 55 degrees north. That means 55 minus 17 gives you 38 degrees north. That's where you're located. And what happens to the altitude of Polaris as you travel northward? Well, let's look. Here's a picture right here. Here you're at 0, and as you go north, it goes to 30, and as you go north, it goes to 90. So it increases. It gets higher in the sky. It gets a higher altitude, increasing altitude. It goes up farther. So increases. With latitude. All right, increases with latitude. All right, so here we go. Refer to the following diagrams to answer questions 21 and 22. These diagrams illustrate systems that can be used to determine the position of the sphere. Oh, look at all these great lines. Systems of lines, such as those illustrated above, are called coordinate systems. How do I know that? Because I read up here and I saw that one of the vocabulary words was coordinate systems. See that right there? And then I read all about it. I looked for where coordinate systems was in bold down here. Ooh, coordinate systems right there. So I read all that garbage and it told me the answer. That's how I learned that stuff. Which of the following systems is most like the latitude longitude system used on Earth? Well, if you look at your notes or any picture from above, you'll see this one is what we see. Burp. So A is the correct answer. 23. How are latitude and longitude lines drawn on a global map? Latitude lines are parallel and longitude lines meet at the poles. Why? That's true. I don't have to go any farther. In the following diagram, what is the latitude of the observer? So here's our horizon, and here's Polaris, and this is a protractor. Each one of these little marks is 10. So that's 10, 20, 30. So this is 30 degrees above the horizon. So the answer is 30 degrees. What is the location of Binghamton, New York? All right, so let's look at our reference table here. Binghamton, New York is right there. And this is 75. So this is 75.5. So this is 75.8. This is 42. This is 43. So this is like 42.2 degrees north and 75.8 degrees west. So let's see what we got here. Well, it's less than 76. So, so this is minutes. So 60 minutes in an hour. So this is really close to it. And this is minutes too. So 1 is our correct answer here. 42.06 and 75 degrees, 55 minutes. That's just short of 76, I mean. All right, 25. Which diagram best represents the altitude Polaris observed near Buffalo, New York? So let's go to our sheet here. Here is Buffalo, and it's around 43 degrees. So let's look and see what's close to 43 degrees. Right here. This one's right here, 43 degrees. Which reference line passes through both the geographic North Pole and geographic South Pole? All right, so longitude, all the longitude, here's 0 degrees, which is a prime meridian, but all the longitude lines go through the North Pole and the South Pole. The following diagram represents a portion of Earth's latitude and longitude system. What are the approximate latitude and longitude of point A? All right, so point A is between 15 degrees west and 30 degrees west, and it's between 10 and 20 degrees north. So 15 degrees north, so it's either 3 or 4, it's not these two. And then we have east or west, and west is the correct answer. So there you go. A person knows the sun time on the prime meridian and the local sun time. What determination can be made? The longitude, right? So all that information is up here where it talks about longitude, using longitude and latitude, measuring longitude, all that stuff, calculating since the sun, 24 hours a day, 15 degrees per hour, all that garbage. It's all up there. Which New York landscape region includes 43 degrees 30 minutes, which is 0.5, 43 degrees, 43.5 degrees north, or 75 degrees, 45 minutes west. So let's look at our, so we got Adirondacks, Tug Hill. All right, so here's Old Forge. So there's nothing on this map. So we're going to have to do 43.5 comes over here, across this one. And then what was the other one? It was 75. So right around here, somewhere underneath Watertown, between Oswego and Old Forge. Let's see, that would be Tug Hill Plateau, right in this area right here. All right, here's Watertown, here's Syracuse, here's Old Forge, Tug Hill Plateau. So let's go back. Tug Hill Plateau is our answer, and that's it. Now you've completed all this. So go back and check your answers to make sure your answers are correct, so you get full credit.